In this video, we're going to take a look at net ionic equations. Now, net ionic equations are a concept that come up in Chemistry 20 and are really important for being successful at redox chemistry in Chemistry 30. So you might be watching this video as a Chem 20 student or reviewing the concept in Chemistry 30. Net ionic equations are concerned with the entities that change in solution. So we need to take the reaction and break it into its entities, and then we cancel out the spectators. And spectator ions are exactly the same in the reactants and the products. So chemicals that are same in the reactants and products aren't actually undergoing a change in solution. So our example of this will be magnesium nitrate. So I've got magnesium nitrate and sodium fluoride, and these are going to undergo a double replacement, so you get magnesium fluoride and sodium nitrate. To balance it, I'm going to need two of these guys, and I'm going to need two of these guys. Now, important for any net ionic equation is that you look at the entities. And so we're going to consult our data booklet, and we're going to see that magnesium nitrate, most things with nitrate are very soluble, so this will be aqueous. Sodium fluoride is going to be aqueous, and sodium nitrate are going to be aqueous. But when we look at magnesium fluoride has a low solubility, or it's slightly soluble. So magnesium fluoride has a low solubility, so it's going to be solid. So it does not break into its ions. So I separate these into the ions. So I've got magnesium ions and two nitrate ions and two sodium ions plus two fluoride ions that are going to form magnesium fluoride, which is a solid entity in water. And then I get two sodium ions, because this is an aqueous ionic compound, and two nitrates. And so this was an aqueous ionic compound, broke into its entities. This is sodium fluoride, broke into its ions, so these are both dissociating. This has got a low solubility, so almost all of it remains solid, and these are going to be floating around in solution. Now if we look, nitrates, two nitrates are aqueous in the reactants and the products. So they are spectator ions, and we cancel them out. Our sodiums are doing the same thing. But magnesiums are becoming magnesium fluoride, and fluorides are becoming magnesium fluoride. So my net reaction is magnesium ions and two fluoride ions create magnesium fluoride. There is still going to be sodium nitrate, but we have to actually dry it out and get it out of solution to be able to retrieve it. This will be a solid precipitate that's sitting in the beaker. And so the net reaction is this. If we did a similar reaction, we could have the reaction of iron with zinc nitrate. So I've got iron solid and zinc nitrate, and it's going to make iron 3 nitrate, because iron 3 is the more common ion, and we didn't have any other information to go on, and then zinc solid. So an element remains as an element. This is an ionic compound, so it's going to break into its ions, and this is an ionic compound, so it's going to break into its ions, and zinc is here, and I've missed a step, right? I didn't balance. So I've got two nitrates here, and I've got three nitrates here, so I need three of these, and I need two of these, so I need three zincs, and I need two irons. So I get two of these, 3 times 1 zinc ion, but 3 times 2 is 6 nitrates, 2 iron 3s, 6 nitrates, and 3 zincs. Now you'll see here that iron has changed its charge from 0 charge to 3 positive. Zinc has gone from 2 positive to 0, but the nitrates are exactly the same. So my net reaction is 2 iron plus 3 zinc ions produce 2 iron 3s and 3 zincs. Now, one of the interesting things and important things is that the net charge here is the same as the net charge here. So we have 3 times positive 2 gives me 6 positives, and 2 times 3 positive is 6 positives. So it's 6 positives on both sides, and we have equal number of atoms as well. So it's all balanced out nicely. We'll go through